Welcome to Ask and Learn.
This is the answer to Chapter 20, problem number 71 from the Smith Organic Chemistry textbook. And this problem asks us to synthesize each compound from the given starting material. And we're told we can use any other required inorganic reagents. Okay, so for A, we're told to start from cyclohexanone and organic halides. Okay, so the first thing that we're going to do is going to be to take advantage of the alkene and use an organolithium reagent to add a methyl group. So since we want to add a methyl group, we'll use the methyl lithium. So CH3 2 CuLi. And then we'll work that up with water. Okay. And so that is going to add the methyl group. So the ketone is unaffected. We now have installed our methyl group here. The next thing that we're going to do is going to be a series of steps to get rid of this oxygen here. So we have this ketone, and we need nothing there, basically. And so one thing that we could do to accomplish that would be, or no, sorry, we have a ketone there. We need a methyl group there. So we can use methyl magnesium bromide, again with a water workup, and that's going to install our other methyl group that we need and set us up to get rid of this alcohol that's here now. And so we can do an elimination using concentrated sulfuric acid. And so we'll get a mixture of products from that. So basically, we can get the elimination product that's going to put the double bond here. We can also get the other product where the double bond will be in the other possible location, which is right here. But it really doesn't matter that we get that mixture of products because our last step is going to be a hydrogenation with hydrogen gas and palladium on carbon. And when we do that, no matter where the double bond is, it's going to go away. And so from either of those materials, a hydrogenation will give us our final product, which is this molecule. Okay, so moving on to B. What does the problem specifically say? Okay, so for B, 1, 2, 3, 4, we're starting from butanol, and we're told that butanol is the only organic starting material that we're allowed to use. So we have an 8-carbon chain with a nitrile in it. And so we're going to need to make this out of 2 equivalents of butanol. And so the first thing that we can do is use PBr3 to go from the alcohol to the bromide, and then treat that with magnesium metal. And so now, of course, we have butyl Grignard reagent. And so, okay, we'll leave that there for now. So then we can take another equivalent of 1-butanol and oxidize that with PCC. And so that is going to get us to this aldehyde. And now we can use the Grignard reagent that we made right below this. With a water workup, as always. And so now we've made our 8-carbon chain here. And we're going to have an alcohol right here, of course, left over from the Grignard reaction. And so in order to get from an alcohol to a nitrile, we're going to have to tosylate it. And then we can displace it with a nitrile, with a cyanide nucleophile. So to tosylate it, we'll use tosyl chloride and pyridine. And then now that we have the tosylate, that is easily displaced with cyanide nucleophile. So let's just say the cyanide ion. And that is going to give us our final product there for B. Okay, so moving on to C. So in C, we're starting from this methyl ester, and we are using this methyl ester and organic halides, and we want to get to a product that is an ether and a brominated aromatic ring. And so the first thing that we can do is reduce this ester. So we'll use lithium aluminum hydride for that. So LAH, water workup. And that is going to get us to the alcohol. Oops. Try that again. Okay, so we're at this alcohol after the LAH. And now we can brominate the aromatic ring. And so this wouldn't be a super selective reaction. So I'm just going to draw the para isomer, but we would get some ortho too. So this wouldn't be, the best strategy for actually doing this, because we'd lose a lot of material, with making the unwanted ortho isomer. But there isn't really another way to get that bromine onto this ring. So, okay. So now we just need to esterify this alcohol. And so remember to do that. We're going to use sodium hydride to deprotonate. And then just use the alkyl iodide of whatever carbon chain we're trying to add. So in this case, it's the ethyl ester that we're trying to make, or pardon me, the ethyl ether that we're trying to make. So CH3CH2I, and that is going to get us to our final product here. Okay, so that's C. Pardon me. D is a pretty straightforward problem. So we want to get from the starting material that we're given to this product, which is a much longer chain with an alcohol in it. And we're not given any other starting materials other than just this one molecule. So I guess we can use whatever we'd like. And so one thing that we could start with would be HBr and some peroxide. And so this is going to do an anti-Markovnikov hydrobromination. And so our product will have the bromine added to the less substituted carbon. And we can then treat this with some magnesium metal to make the Grignard. Okay, and then we can use this Grignard. So we need to add 2 carbons and an alcohol here. And so we can do that just by using oxirane and using the Grignard as a nucleophile to open this epoxide. And that is going to get us to our desired product. Okay, so there we go. There's D. And then lastly, for this problem, for E, what does E say? So for E, we have to go from acetylene to this much larger molecule. And we're told we can only use compounds having less than or equal to 2 carbons. Okay. Okay, so we need to start by building this carbon chain. I'm going to do this all as a single step here. So if we take acetylene and we treat it with sodium hydride, that's going to deprotonate it to make an acetylide ion, which can act as a nucleophile. And then we'll use acetaldehyde. Oops. Followed by water workup. And so that is going to give us this. Okay, so we now have a 4-carbon chain. And we need to protect this alcohol that we just made so that we can keep manipulating the rest of this molecule without the alcohol interfering. So one way that we can do that is TB DMS protecting group. So we can introduce that with TBDMS chloride and imidazole. And so when we do that, we then get the protected alcohol. And now we can use sodium hydride again, and rather than deprotonating that alcohol, it's going to deprotonate the alkyne. And so we'll make another acetylide type ion. All right. Well, I apologize. My computer seems to have frozen. Okay, there we go. T, B, D, M, S. All right. So we have our acetylide type ion here. And to add our last 2 carbons and the alcohol that we need, the terminal alcohol here, what we can do is open an epoxide with this acetylide nucleophile that we've made. So we'll use oxirane and work it up with water. And so that is going to get us to here. So now we've added these 2 carbons, and we have our alcohol, and we still have the protected alcohol up here. And so the very last thing that we need to do in order to get to our final product is going to be the deprotection of the TBDMS group. And so in order to do that, we can use tetrabutyl ammonium fluoride. And so that's commonly abbreviated TBAF, tetrabutyl ammonium fluoride. And that is going to give us our alcohol back here. And the rest of our molecule has been built. There's our triple bond, 1, 2, and the other alcohol. Okay, and so there's our final product for E. All right, and again, this is another synthesis problem, so there's no way to answer this other than knowing every single one of these reagents and what they can and can't do, and how to use them in sequence. And that's the answer to chapter 20, problem number 71.